Hello and welcome back to Mrs. Hauk's math lesson. You will notice on the whiteboard in front of you it says greatest common factor. Greatest common factor, remember, is the GCF. We talked about it yesterday and we're going to kind of review it a little bit today, and I'm going to show you another way to possibly find the greatest common factor. Remember, factor is something that it's a number actually that we multiply times another factor to get the product. So if you guys could open up your math book to lesson 18, we're going to kind of do a few more pages here in lesson 18, and it's on page S79. It looks very similar to this. We did this top half, and we're going to actually do something here on the bottom. We're going to actually find the greatest common factor for 42 and 60. I'm going to have us go ahead and do it the way that we've been practicing. So if you remember, we're going to list all the factors of 42, and then we're going to list all the factors of 60. All right, so we're going to list the factors for 42. If you have this kind of a cheat sheet here, you can notice I have them all listed here. Otherwise, you can do them in your head. So we're going to go ahead and list the factors for 42, which are 1, 2, 3, 6, 7, 14, 21, and 42. Okay? Okay, and we can always check it by looking here at the rainbows to make sure we have 1 times 42, 2 times 21, 3 times 14, and 6 times 7. All right, now we're going to go ahead and we're going to list the factors for 60. And once again, if you have a little cheat sheet that looks something like this, you can use it. You notice that there's a lot of factors for 60. So we have 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Whew. These are obviously not prime numbers because they have so many factors. So if we would go ahead and circle the things that they have in common, we have the 1s, 2, 3. They both have 6s. 7s, 14, 21, 42. So it looks like that's it. So the greatest common factor, if you notice here, would be 6. Now, if you don't have a factor sheet like this to use, or you don't know your multiplication facts that well, another thing you could do is something that looks like this. And go ahead and write this in your book. So we're going to put here, over here we'll put the integer 42, and over here we'll put the integer 60. We're going to make a factor tree. So that means I need to think of two numbers, any two numbers that you want, that you can multiply to get 42. I'm going to go ahead and put 6 and 7. All right, now let's look at the numbers 6 and 7. Is there anything that I can multiply together, two factors that make 6? Now the only rule is I can't put a 1. So for example, 7, the only thing that makes 7 is 1 times 7. Well, we're not going to do that because 7 is prime. It won't go any smaller. So I know that 2 times 3 equals 6. All right, there's nothing that I can multiply to make 2 besides 2 and 1, and nothing for 3. So I have here already, I have the 3 prime numbers. So these are the prime numbers for 42. Let's go ahead and do 60. All right, two numbers that I multiply to make 60. I'm going to just do 6 and 10. All right, what can I multiply together to make 6? 3 and 2. And over here, I can do 2 times 5 to make 10. I think these are all prime numbers. So we're going to go ahead and circle them. Okay. Now what I'm going to do is I'm going to look to see at what they have in common here. So I could make here like a Venn diagram, put a circle here and a circle here. This is going to be for the 42. And this is going to be for the 60. All right, most of us know in a Venn diagram the numbers that they have in, or something that they have in common goes in here. If I look at my factors here, I see that we have a 2 over here and a 2 over here. So we'll put that, they have that in common. Oh, they both have a 3. They both have that in common. This has a 7, this doesn't, so that would go over here. And then over here we have a 2 and a 5. All right, so we look at the numbers that they have in common right here, 2 and 3, and all we do is multiply them. So we would say that 2 times 3 equals 6. So the greatest common factor is 6. And we actually found that up here as well. So you can do one of two things. You can either list all the factors and find the greatest common factor, or if you're afraid you might forget a factor, you could make here what we call is a prime factor tree, where you factor down here and you find what they have in common, and you will get the same answer. All right, go ahead and turn, please, over to the next page. All right, so we're going to kind of scribble this out here. We're going to do kind of a little review. We're going to continue finding the greatest common factor. Remember, we're finding factors. I'm going to ask you to find the greatest common factor, and let's do 16 and 34. All right, in order to do a little practice, I'm going to ask you to go ahead and pause your video and see if you can solve this on your own. It's good practice because we're going to have a test on this on Friday, and I want you to list all of the factors for 16 and all the factors for 34. If you have your cheat sheet, you can do that. Otherwise, you can try and do it in your head. All right, so if you notice, I have the factors for 16 as 1, 2, 4, 8, and 16. Now, if you notice, we have 1 times 16 is 16, 2 times 8 is 16, and it's 4 times 4, but we don't need to list the 4 2 times, so it just kind of be like 4 times 4. We have here 1 times 34 is 34, and 2 times 17 is 34. All right, so if we notice the numbers that they have in common, they both have a 1, and they both have a 2. Those are the only numbers. So the greatest common factor would be 2. Okay, so remember, we're talking factors. Factors. These are factors. This is not multiples. All right, let's try one more. All right, so we're going to go ahead and cross out these words here. And we're going to go ahead and find the greatest common factor for 42 and 21. So once again, I want you to list the factors for 42 and 21. All right, so if you want to look up here on my screen, you'll notice I listed all the factors. What are the factors of 42? Well, 1 times 42, 2 times 21, 3 times 14, and 6 times 7. The factors of 21 are 1 times 21 and 7 times 3. If I circle the ones they have in common, I see here a 1, a 3, 7, and 21. So the greatest common factor for this answer would be 21. Okay, now to help us remember, these are factors. If I would ask you to do, and let's go down in this spot here, and let's write here, the letters LCM, least common multiple. So we'll write them like this. Now, if you think about it, the least common multiple is different than factors. Multiple means I'm going to count by 42s, and I'm going to count by 21. All right, so if I count by 42s, we have 42 times 1 is 42. 42 times 2 is 84. 42 times 3 would be 126. And then if I did 42 times 4 would be 168. So we're counting by 42s. Remember, these are multiples. Now we're going to do 21 times 1, 21 times 2, and if you need to do this, you could do 21 times 2, and you will notice we get the answer 4. Oh, look at that. I get to actually stop, because if you notice, I already have the least common multiple. And I could add some more on here if I wanted to, but there's really no reason to, because I found the least common multiple. So now if you notice, we have two different things. Greatest common factor, I'm listing the factors that make 42. And then I'm circling the greatest number. Least common multiple means I'm listing the multiples. I'm counting by that, and I'm circling the least or the smallest number. Okay? All right, so I'm going to have you guys actually flip over. If your teachers want to go over with the distributive property with you later, they sure can do that. But I'm going to have you guys flip all the way over here to this page where we kind of have some empty room to write. Okay, so we're going to do a little bit of practice here. We're going to put here greatest common factor, and I want you to find the greatest common factor for the numbers 2 and 8. And then we're going to come down here and we're going to do the least common multiple for the exact same numbers. And we're going to start seeing if we can understand what we're doing. Remember, we are looking for factors, numbers that we multiply. So let's look here. We have the number 2. What can I multiply to make 2? 1 times 2. It's a prime number. What do we multiply to make 8? Well, 1 times 8 and 2 times 4. All right, so we've listed the factors. Remember, we're looking for the greatest. The greatest factor I see here is 2. Make sure you are writing this down in your book. Now we're going to do the same numbers, but this time we're going to do multiples. All right, so we're going to write here that M is for multiples. We're going to count by 2s. So we go 2, 4, 6, 8, 10, 12, and we'll stop there. Then the other one we're going to look at is we're going to count by 8s. Whoops, let's fix that there. 8 times 2, 8 times 3, 8 times 4, and 8 times 5. All right, now remember we're looking for the least common multiple. So now I'm looking for the number that is the smallest that they have in common. Well, it looks like the smallest number they have in common is 8. Okay, so you can notice, even though I use the same integers 2 and 8 and 2 and 8, when I'm dealing with factors, I have the answer 2. And when I'm dealing with multiples, I have the answer 8. Okay, I'm going to ask you just to turn the page to this blank screen right here, blank piece of paper, and I'm going to ask you to go ahead and practice on your own greatest common factor, and I'm going to give you the numbers 4 and 12, factors, remember, and then I'm going to ask you to do the least common multiple, and I want you to do the same numbers. All right, go ahead and pause your video and see if you can do this on your own. Okay, so if you notice, I have listed the factors for 4 and 12. Okay, we notice that we have 1 in common, we've got 2s, and we've got 4. So the greatest common factor, we would say, is 4. Okay, now let's see if least common multiple is the same thing. Okay, so if you notice, least common multiple, remember multiples, now I'm counting by 4s, I'm counting by 12s. So I have here 4, 8, 12, 16, 20, and then I had 12, 24, 36, and 40. Now if you notice carefully, I don't have a number in common. So what am I supposed to do? Well, then that means I need to keep counting until I find a common multiple. Because the 12s are already at 40, and 4s are only at 20, we're going to continue counting by 4s. So if you notice, the next number that I would count by would actually be the number 20. 24. And once I do that, you will notice that now I have a multiple in common. Okay? Now what's interesting is you will notice that most of the time, the least common multiple, the answer that we get should be larger than the integers we started with. Our greatest common factor sometimes will be equal to one of the integers, or it's probably going to be less than one of the integers, if not both. Okay? All right, so today I'm going to have you practice on your own. You're going to do the difference between greatest common factor and least common multiple. Keep your book handy in case you need it. This is the paper you're going to need here, multiplication chart for your multiples, and then the one you might want for your greatest common factor will be a factor sheet. All right, well, have a great afternoon, and I will see you all tomorrow.